Here we are using the RF power meter to measure the frequency response of a 5 MHz low pass filter, which consists of a couple of T sections joined together. In other words, it's 3 coils and 2 capacitors. The power meter has 2 probes, so we've put one of the probes across the input and the second probe across the output. Both probes are 50 ohms and the filter was designed for a 50 ohm source and 50 ohm load. We have a leader signal generator set at 5 MHz and the output of the signal generator is set to -10 dBm. As can be seen currently here on the digital display and the analog display. The meter is currently switched to the input of the low pass filter. I'll switch to the output. That is now the output of the low pass filter. I'll just pull out so you can see that we're now connected to the output. You'll see the LED lights light up as I switch between the input and output. There we go. -10 is the input and -10 is the output. So at 5 MHz the filter is straight through. I will now increase the frequency of the frequency generator. Currently it's 5 megs and we're looking at the output of the filter. So as we move upwards, 5.25, 5.5 megs, 5.75, 6 MHz, 6.5, 7 MHz, 8 MHz, we've dropped to -40, which means 30 dB loss or reduction. 9 MHz is there, and here we have 10 MHz or 1 octave higher up, and the signal has now dropped to -53.6 dBm. So the filter loss at 10 MHz or twice the 5 megs is 43.6 dB down. Having the 2 probes, one on the input and one on the output, on the power meter and simply switching between the two makes the measurement of this type of circuit a lot easier than moving the probes around and disturbing the layout of the circuit.